Okay, let's jump right into it. Welcome to the Explainer. Today, we are looking at the ultimate engineering showdown, and that is specifying aluminum versus steel cable trays. Now, if you are out there designing or managing critical infrastructure, you already know this choice is a massive deal. It literally impacts every single stage of construction.
But what actually decides the aluminum versus steel debate? It's a question that sparks endless, and I mean endless arguments in engineering firms all over the globe. Well, I'm going to tease you right off the bat here and say that the real driving force behind this choice is probably not what most people look at first when they pull up their project spreadsheets.
So, the crucial point is, the decision actually comes down to four critical pillars. We're talking load performance, support spacing, corrosion exposure, and the long-term maintenance consequences. Now, do you notice what is not on that list? Yep, material price. We have got to debunk this myth right now. While upfront material costs are super easy to compare, the hard engineering realities dictate that those four factors you're looking at are what actually define the success and, ultimately, the true total cost of your installation.
All right, so let's kick off round one, the physics. Specifically, why stiffness governs before strength.
There is a clear, absolutely crucial distinction here between strength and stiffness. When you're specifying a tray, your brain might immediately jump to strength, right? The ultimate breaking point, its ability to hold up a massive, heavy load without just snapping in half. But in reality, stiffness, which is the material's resistance to bending or deflecting under that load, that is what governs the design way before strength even becomes a limiting factor. You definitely do not want a cable tray visibly sagging in the middle of your facility, even if it's technically strong enough not to break.
And this perfectly illustrates exactly why that physical property matters on the actual job site. Because stiffness dictates our design limits, it directly dictates your support spacing and your span selection. Aluminum is generally more flexible, so what does that mean? It means it requires very specific, often much closer support spacing to prevent that exact sagging we just talked about. Steel, on the other hand, gives you a completely different span selection because of its naturally higher stiffness. You can often push those structural supports much further apart with steel, which totally changes the architectural and structural layout of the entire project.
Let's move to round two, the elements, and see how this builds into surviving corrosive site conditions.
When we look at corrosion behavior, you really have to think long-term about the lifespan of your critical infrastructure. Aluminum natively develops this natural oxide layer that helps it hold up beautifully in a lot of harsh, wet, or super demanding environments right out of the box. But steel? Well, if you place raw or improperly treated steel in a highly corrosive site, it is going to fail first. For sure. It'll rust, degrade, and rapidly compromise the structural integrity of your whole cable management system. Think about the massive maintenance consequences of replacing a failed, fully loaded cable tray years down the line. It's a total logistical nightmare. You have to perfectly match your metal to the specific site conditions.
Okay, moving on to round three, the project balance. Installation time versus project economics.
This quote really hits the nail on the head regarding the fundamental trade-off you have to navigate. Where aluminum saves installation time, steel wins on project economics. It is a really delicate balancing act that requires you to look way beyond just buying the raw materials. Let's explore exactly why that happens. Let's break this head-to-head matchup down a bit. On the immediate labor side, aluminum is incredibly lightweight. That means your installation crews can move it, cut it, and install it so much faster. It translates to less fatigue, less need for heavy lifting equipment, and it saves you incredibly valuable installation time when you're on a tight construction schedule. But when we shift gears and look at long-term value, steel often takes the crown for overall project economics. Why? Well, just like we talked about back in round one, its stiffness allows for longer span selections. That means you need fewer supports, less associated hardware, and potentially even less structural reinforcement needed in the building itself. Depending on the scale of your facility, those material and support savings heavily outweigh the extra labor time.
Which brings us to the resolution, the final specification checks.
Before you lock down any specification, you absolutely must execute these 5 crucial checks. You have to synthesize the exact load requirements, the necessary support spacing, the precise corrosion exposure of your site, the long-term maintenance impact, and finally, how all the specific fittings and accessories will connect together as one unified system. Only when those 5 checks are entirely aligned should you go ahead and finalize your material choice.
And look, when you're making these high-stakes decisions, you really need a manufacturing partner with serious pedigree. That is where Xinma comes in.
Shanghai, Xinma, Busway, and Cable Tray Co. Ltd. They engineer for critical infrastructure, manufacturing not just the cable tray systems themselves, but the whole shebang: busways, seismic bracing, and intelligent cable management solutions that really bring modern facilities to life.
Notice how brilliantly their engineering maps directly to global standards. You can see their strict compliance with IEC, NEMA, BSN, and GB standards, right there side by side with the demanding industries they serve. Whether you're dealing with the massive, heavy data loads of modern data centers, the intense vibration concerns of rail transit, the harsh environments of industrial plants, or just the complex layouts of commercial buildings, they have the proven trust and certifications to meet those rigorous, uncompromising specifications.
So, I'm going to leave you with this provocative thought as we wrap up today's explainer. Have you prioritized material price over stiffness and corrosion in your latest specs? I really challenge you to take a second look at your current project pipeline based on the physics and economics we just walked through. Reevaluate those designs, ensure you've actually done the 5 checks, and make sure your infrastructure is truly built to last. Thanks so much for diving into this with me, and I'll catch you on the next explainer.